So without further ado, I'll hand over to our presenter, Hayfin, to talk you through RStudio.
Cool, thank you. Thank you for coming, guys. So everyone has got R and RStudio installed on the computer. So if you want to open RStudio, I think the way that, I think the best way for this workshop to work is basically, as long as you can all see see what I'm typing, I think the best way is probably if you type along with me. So if I go too fast, or if something doesn't work, or you get an error, or something confusing happens, please just shout out and let me know, because I think it's really important that everyone sort of goes along with it, because you can get lost quite easily. So R is super cool. It's a statistical programming language, and it looks a bit daunting because it's not sort of a GUI-based application where you can click via menus and get the analysis of the graphs that you want. You do everything by the command line, by typing text. So it can seem a bit complicated, but when you start using it, actually, it's not as complicated as it seems. And the best way to get to grips with it is to go to a couple of workshops and practice and play around with it yourself, and then look at some online tutorials, and eventually you'll sort of come more to grips with it. So I think this is going to be split into two parts, and it sort of depends, I guess, on where we finish. But in my head, I've got it that we'll start off just by working with R within RStudio. So R is the language, and people used to work in R just like this at the command line, with no sort of application to help them, just sort of typing things at the command line. And then if you wrote some code that you wanted to save for later on, you'd have to open up Notepad and save it in the Notepad and do it that way. Whereas RStudio is an interactive development environment, they call it. It's basically a fancy way of saying a program that makes it easier for you to run R. So and everyone who does things in R these days does it in RStudio. So we'll talk about using RStudio. We'll talk about how you can perform mathematical operations in R, because at a very basic level, R is just a big glorified calculator. We'll talk about creating objects in R and working with them. What I mean by data classes, so whether something is a numeric, a character, or a logical. Data structures, so the way that R likes to store little bits of information in a way that we can work with and manipulate. Functions, which are operators that take an input and give you some kind of output. So an example is the mean function, where you give it a list of numbers and it'll give you the mean afterwards. Exploring our data, so say we generate or read in some data into R, we want to explore the data and see if there are any relationships there. And then we'll look as well at how we can read data into R from an external source. So I think most of the time, most of us will generate data that we put into or organize into some kind of Excel spreadsheet that we'll then want to import into R to work with. And as part of the email that you guys got, there's an example data set called Pokemon, which we'll probably end up, I'm hoping that today we'll end up reading into R and having a quick look at, but then in the next session, a week later, we'll actually start looking at analyzing that data and doing sort of your t-tests, ANOVAs, two-way ANOVAs, and post-hoc tests and things like that. So everyone's got R open. Does everyone have something that looks a little bit like that? It might not be blue. You okay?
Also warning messages now?
Warning messages already.
Yeah, yes. I mean, everything goes into here, but then is during the initialization.
Okay, can you translate that for me? What does that say in English?
During the initialization, warning messages, and I set it, and all these settings fail. But they didn't even have this warning message when I installed the plugins and stuff.
Okay. I've not seen that before. Let's carry on.
Okay.
If anything weird happens, let me know, and we'll try again. So, everyone has something that looks a little bit like this. And can you read this, by the way, this white text on a blue background? That's okay? Okay. So, first thing I want you to do is go up to the top left corner and just click on this white sheet and say that you want to create a new R script. And then you should get something like this. So that your screen is basically split into 4 different places, okay? So, start in the bottom left-hand corner, what they call the console. This is, you can think of actually what R is. This is the body of R. and this is where the R code is actually executed. Up here is the script, where basically you can store your R code as you type it through. That'll make more sense in a second when we use it. On the top left, you've got an environment and a history tab, which we won't really use so much. We'll see it being used when we use it, but it's not so important for this first one. And then down in the bottom right-hand side, you have this section that you have a little file browser for your computer. Any plots that you generate appear in this tab, and if you look for any help for any packages and things, they appear in here as well. So if you just start down in the console, you can think of this is R that's actually running. At its very basic level, R is a glorified calculator. So if we start using some mathematical operators, so 2 plus 2, and then hit enter, R will run the code and it'll print the output for you. So 2 plus 2 is 4. So everyone happy to type along as I go? You can also forget the space if you want and just do 2 plus 2 without any spaces, but it's generally considered better to make your code more readable to have spaces between operators. So addition, 7 minus 8, minus 1. Multiplication is the asterisk. Oops. 4 times 6. And you can combine these together in the same kind of way that you would if you were writing some kind of equation. So you can do, I don't know, 2 plus 2 divided by 3 to the power of 4, and hit enter, and then you get the result. Yeah, so everyone is happy with that at the moment. So R is a glorified calculator, by the way, at a sort of very basic level. What you'll notice is that as we type code and hit enter, the previous code that we've run sort of moves further up the screen, and eventually you can imagine that if you are typing huge amounts of code, this sort of gets lost up the screen, and then you've got to scroll through and try and find it, which is quite difficult. If you either make a mistake or you want to find something that you typed earlier, if you keep tapping the up key, you'll see that it will cycle through the most recent commands that you made. And if you go down, you can scroll and cycle between the ones, and if you find the one that you wanted, you can just hit enter. So this is R, but actually a better way of keeping track of what you've typed and keeping track of which bits of code work and which bits are rubbish is by using the script up here. So if you'll click on the top left panel. So up here, if I type 2 plus 2, and hit, so if I hit enter, I just go to the next line and nothing happens. If you hit control and enter, what happens is the script passes this line into the console, basically gives the line of code to R, and R runs it. So R then says this is full. And I can keep typing code. And although my code that's been executed sort of disappears up the screen, the code that I've written in the script stays. It's sort of like a text file that you can put all the bits of code in it that work well, and it's easier then to go back and say, oh no, I didn't want 2 plus 2, I wanted 2 times 2, and hit control and enter. So most of the time, when you're writing R code that you are interested in keeping or editing and perfecting, you want to be writing it inside the script. And also, you can save the script. So you can save it as a .r file and then open it up again. And anything that you've written in there, just like a text file, will be in there next time. In R, everything is an object or can be saved as an object. So if I want to save the value of 10 times 6 so that I can reuse it later, say I want to call it A, you type the name of whatever you want to call the object, and then this funny little operator, which is the assignment operator, which is, you can see it's an arrow pointing to the name. So you can do it either way around. People tend to have the name of their object on the left, the assignment operator, and then whatever the value is on the right-hand side. So this basically tells R, take this and assign it to an object called A, and hit Control Enter. And you can see now that over here in our global environment, we've got an object called A, and its value is 60. And so if I type A and hit Control Enter, it gives me the value of 60. So the result of this is stored in this. Does that make sense? So it's the less than sign followed by a dash, a minus sign. Yeah. Okay. In R, anything that follows a hashtag is ignored. So it's purely for you to write a comment to remind you of why you've done something. So assigned object A. So I hit Control Enter, and all R sees is the A, and it just gets bored when it gets to the hashtag, so it doesn't read anything else. So this is really useful to comment bits of your code so that you remember why you did certain things, so that when you come back to it later, you don't sort of think, oh, why the hell did I do that? And a really useful thing in RStudio as well is that if you include a comment line that ends in 4 dashes, then a couple of useful things happen. So hang on, let's say this is part A, part B, and let's just type hello. So first useful thing is that when you do this, so you start a line with a hashtag, have any text that you want, and 4 dashes. It indexes that part in RStudio so that you can easily flip between different sections, which is useful. So you can use these basically as section headers. And another useful thing is that you see that when you do this, you get this little arrow. I don't know if you can see that, or you can see on your screens alongside the line. And if you click on the arrow, you can collapse certain bits of code. So if you've got a massive piece of code that you don't want to see when you're scrolling through, you can click on that and toggle it open and closed. Does that work for everyone? Mm-hmm. Would you rather that I had it white? Or is it just you're just curious how to? Okay, so if you go to Tools and Global Options, and then Appearance, mine is on Cobalt. But there are loads of different ones that you can choose from. Mm-hmm. That's okay. Okay, so we know how to create objects. So you give the object name, you give the assignment operator, and then whatever value or equation or even plot that you've got on the right-hand side. So let's call this. R is case sensitive, so if I create an object with a capital A and give this the value of 67 and enter, if I call capital A, I get 67, and if I call lowercase a, then I still get the 60 that we assigned over here. So R is case sensitive for everything, actually. So it's just because it's the same word doesn't mean it's the same object. You can overwrite objects. So if I reassign A to 2 and then call A is now 2. So you can overwrite something just by reassigning a different value to it. Does that make sense? And R has conventions for naming objects. So you can't just name anything anywhere that you want. So, for example, you can't name something with a name that starts with a number. So if we run that, it says unexpected symbol in one object because it doesn't like you having something named beginning with a number. It also doesn't like having names that have special characters in, like exclamation mark. Nope, not happy with that. Or with a minus. Oops. Not happy with that. And actually, even if I put the exclamation mark at the end of the name, it's not happy with that either. What you can do is have numbers at the end, so you can have object 3. That's fine, so we can call object, object 3, and it returns the value 3. If you want to name something some kind of phrase that might have spaces in it, there are a few different ways that you can do it. Well, you can do it any way that you want, but you might either see something like that with a dot where you might put a space to make it easier to read, or an underscore, or camel case, which is where you don't put any dot or underscore between the words, but every time you start a new word, the first letter is capital. So these are fine. R accepts these. Most of the time, you'll probably see these two. I generally prefer camel case, but if you prefer underscores, then you can do whichever way that you prefer. If it's not clear to you, by the way, at the moment, why we're creating objects, it will later. It's just so that you have some way of storing a value, or it could be a data table or a plot, with a single word that you can call and do later on. So rather than having to create one massive long equation that you type out all in one go, you can create it bit by bit and then just feed the objects into an equation. If you want to remove an object, then we'll talk a little bit more about functions later on, but there's a function called rm for remove. So you type rm and then put whatever object you want to remove inside brackets. So if I want to remove my object and hit Control Enter, then we find that my object has disappeared from our environment. So sometimes you've got something that you don't want anymore, you just want to get rid of it, then you can do it like that. So R is built obviously for statistical analysis or programming, and it has certain classes or certain ways that it likes to classify data, because different processes apply differently to different types of data. So what I mean is, you can have data that is numeric, is based on numbers. You can have data that is based on characters, so text, or you can have logical data, which is basically either true or false. And it's important to understand that they're different because R handles them different for different processes. So, for example, that is numeric. So is that. So is that. Whereas that is character. So numeric is always a number, obviously, and you can see that R is, at least on my color scheme, has made this pink, and it's just written as the number itself. For text, for character, each item, each little piece of text data needs to be surrounded in double quotes, and that's the way that R understands that it's character. If I do that, then it says male. It basically just passes it back to me because I haven't done anything with it. But if I try and submit it like that, it says object male not found, because it's no longer looking for, it no longer sees it as a character, it sees it as an object that we've named, but it can't find that because we haven't created it. So character strings need to be in quotes. And then the last type of data class is logical. So this is obviously either true or false, and you can see that R's coded it in pink because it recognizes that it is basically that it's not character. They have to be in capital letters, so that you can see isn't colored differently. That isn't a logical value. That would just look for an object called true. Similarly, that's also not a logical data value, but you can abbreviate them to T and F for shortening. It might not be obviously clear why you would need to use logical data values, but they're often useful for options, for functions. So it might be that you run a function that plots a regression line, and it has an option whether you want error bands, and you can supply true or false, and then that will plot that differently. So most of the time when working with data, we're often not just working with single data values, we're working with collections of data. So it might be a data table or a string of results or a set of random numbers or something. It's not just a single value. And R organizes the data, or likes the data to be organized into certain structures. So again, it likes to perform certain things with certain functions. That isn't very clear, but it will be clear, I promise you. So there are a few main types of data structures, basically ways that data are organized and represented in R. The three most important ones are probably vector, list, and data frame. And actually, initially, people probably aren't going to use list very often. We'll play with these in a minute, and it will become more clear. I promise everything will come together. A vector is basically like a series of single values. So it could be a series of weights of different people, a series of drug doses. It's just a single row of data. And the data is all of the same class. So the data is either all numeric, it's all character, or it's all logical. Similar to a vector is a list, which again is like a single row of data, but it can be lots of different types. So you could have character mixed in with numeric, mixed in with logical, and also a list can be a list of lists. So you can have a list embedded within a list, you can have a plot embedded within a list. So it's a way of storing lots of different complicated data types together, which, to be honest, most people initially don't play with lists that much. A matrix we won't really talk about here, but you may come across it, is basically like a 2D version of a vector. So instead of just having a single row of data, you have rows and columns of data, but they're all the same type. So they're either all numeric or all character or all logical. And probably the most important one for us, as well as with vector, is a data frame, which is, you can kind of think of really as loads of vectors pasted together as columns. So it might be that every column is a different variable. So you could have one column is group and the other one is response. And so within each column is a single data type, so it could be numerical, character, or logical again, but they're all pasted together. So this is probably, you can kind of think of it as if you've been using Prism, then the table that you put your data into in Prism is a bit like a data table that you find in R. So it's a way of organizing your data in a way that you can use for your analyses, your plots. So we'll talk about that in a second. So the first one is a vector. Oops, that's not how you spell vector. Is everyone with me so far? I know that nothing has sort of come together yet, but I promise you it will make more sense. So if we want to create a vector of data, which is just a series of values that are of the same type, we use this function C, which stands for combine. And again, we'll talk more about functions later. We know it's a function because it has a name and it has two brackets. And then you put its arguments inside the bracket. So let's say that we want to create a vector that represents patient ID. So we've got 10 patients in our study. So to create a vector that basically has values 1 through 10. So we can do that by putting the values in and separating them by a single comma. You don't have to put a space, but the standard in R is to put the comma and then have a space to make it more readable. So we've got our values 1 through 10, and then if you hit Control and Enter, it pastes out our vector. So all a vector is just a series of values that are of the same type. So without being patronizing, what kind of vector is this? What data class is in this vector? They are integers, yeah. Take one step back from integer. Yes, it's numeric, yeah. Another way, an easier, quicker way that we can generate a series of numbers is using the colon symbol. So if we say 1:10, that basically says generate the sequence of numbers between 1 and 10. So if you hit Control and Enter, then it basically pastes out exactly the same. So it's shorthand rather than typing out every single number. You can imagine that if we wanted to generate a vector of 10,000, then you wouldn't want to type all that out by hand. So you can do that quickly by using the colon. So that's a numeric vector. We can make a character vector in basically the same way. So maybe we want to make a vector of days of the week. So remember, for it to be a character, it needs to be inside double quotes. So let's do Monday, separated by a comma, Tuesday, etc. Let's just go as far as Friday. So inside this combine function, we've got this is a character element, Monday, this is a character element, this is a character element, and they're all separated by commas. So what this combine function does is it sticks them all together into a single vector, and this is a character vector. So if we print that, then we get the vector printed out. And you can see when it prints them out with quotation marks as well. And the quotation marks are important. So if I try and do the same thing, but without quotation marks, then it says object mon not found. Because it's not in quotation marks, R is looking for an object called mon, and there isn't one. We can have a vector of logical values. So we can have not to true, true, false, and hit Control and Enter. And then again, we get a vector of logical values, which doesn't work if we do true, true, false, because it's looking for an object called true. But what you can do is abbreviate true and false to T and F, and R is happy with that. It expands the T and the F to true and false. Earlier we talked about creating objects. So you can assign vectors to objects. So let's create a vector called my vector. And I want to assign to this object. Let's assign this. So if you want to copy and paste and make it easier. And then hit Control Enter. So it's stored this vector inside the object called my vector. And then if I type, let's do this in here. If I type my vector and hit Control Enter, then it prints out the true, true, false vector. Let's create another one, an object called numbers. Assign to this object the numbers 1 through 10. Control Enter. And then if I call numbers, again, it prints me the vector. So is everyone happy with that? That we can create vectors of data, assign them to objects, and then call them into R. The reason the vectors are kind of important is you can imagine that if you're inputting your data manually into R, you can do it via vectors. So you could create a vector for group, a vector for response, and then paste them together into a data table and use that for your analysis. You can perform mathematical operations with vectors. So we've created this vector numbers, and let's say I don't just want the numbers 1 through 10. I want to find out what the value of every number in my vector is times 2. And if you run that, you can see that R performs this times 2 operation on every single element inside our vector. And we could do this with different operations, so +3. And we can even add different vectors together by name. So let's add this to itself, and which is, of course, is the same as doubling it. So not only can you save vectors as objects, you can use those object names to manipulate them. Okay, so we've talked about vectors. The other, I guess, similar data structure to a vector is a list. We won't spend too much time talking about them because you probably won't find that you use them quite as often.
Sorry, Nathan.
Yeah.
I don't want to interrupt.
No, please do.
Your function for the 4 dots at the end, is that part of the base code? Because that doesn't seem to be working.
The 4 dots, what's that to me? Oh, what do you mean?
To split everything into sections.
Is it, so they're 4 dashes?
I find dashes work. 4 dashes.
The 4 dashes. Is it because it looks like dots on the screen? Oh, I'm sorry, yeah. So they're 4 dashes. So if you do that, then, so like it, this, actually I haven't been doing it. If I want to collapse this whole vector section, then I can click here, and that collapses it away. And also, if I want to go right the way back up to where we started in objects, I can click on there like that. Yeah. Sorry, guys. That's okay. Does that make sense? Yeah, I know it's not great on the screen. So a list is similar to a vector, except that it's a little bit more flexible in that it can accept, a single list can accept different kinds of data. And you can have lists within lists, you can have regression models within lists, you can have plots within lists. So it's a way of storing lots of data. So if the function for creating a vector was C, the function for creating a list is handily list. So let's create a list with the values 1, 2, 3, 4, 5. Oh no, wait, sorry. Let's go as far as 3. Let's not go nuts. And then, so we've got 3 numeric values. Let's add a character. Hello. These are all separated by commas. And then let's add a logical value in at the end as well. False. And hit Control Enter. And then you probably can't see this on my screen. And also, if things don't fit on your screen, you can move things around in RStudio to however is useful. So you'll see that a list is printed out a little bit differently than a vector. So a list, the main elements of a list are printed down your screen instead. So this is element 1, was the number 1. This is 2, this is 3, this is hello, and this is false. And it might seem a little bit weird as to why it does that. But the reason is because you can have lists within lists. So you can imagine that the first element could be 1, the second element could be 2, the third element could be a list with the values A, B, C, and then they would be shown horizontally across your screen. Let's have a look at what I mean if that's completely confused you. So we created this earlier, my vector, so that's still in our environment, and it's a vector of the values true, true, and false. So let's create a new list, and let's start it with my vector, and we can just call the object name, and R will see this. It'll look through your environment, find my vector, and it knows that it's a vector of these values. So the first element in the list is my vector, and then let's go 1, 2, 3, oops, hello, and
So if the words, they don't have to be the big letter.
say it again, sorry.
Hello is not like in the big letter, it's like a font. Hello with small letters.
So it could be whatever I want. So if I want it to be hello, then we can do it like that instead.
So because there was like Monday, Tuesday, it was like sensitive, yeah.
No, so they weren't sensitive to the case. It was just that they need quotation marks. Yeah. If I'd written it all lowercase, then it just would have printed it out as lowercase. So if you need it to be capital or lowercase, then you can do it as you need it. So now if we hit Control Enter, let's have a look up here again. So now you can see that the first element in the list is the vector, which has 3 values, true, true, and false. And then the other elements then are just individual elements. So does that make sense how a list operates differently to a vector? And maybe could be useful. Why can't I find the... Oh. Oops. There we go. We can also... This 1, 2, 3 in the middle... if you wrap that, actually, don't write new. Let's save us all some typing. If we actually, instead of having individual elements 1, 2, 3, let's make this a single vector. And now hit Enter, Control Enter. now it's done the same thing but with 1, 2, 3. So the first element in the list is the vector true, true, false. The second element is the vector 1, 2, 3, and then the third is the character string hello, and the fourth is a logical false. Okay. If that's confusing and doesn't make sense to you, don't worry about it. Vectors and data frames are the most important data structures that you're going to be doing if you're doing data analysis, at least initially. So the next most important data structure is a data frame, but I'm going to come back to that a little bit later because I want to talk about how you can subset vectors. So oops. Is there anything that has really confused anyone so far? No? Everything? So, let's copy and paste these days of the week and save them in an object called days. So if we want to print out days, then it just prints out these days of the week. Oops, let's make that a bit bigger. So let's say, so we have our vector, days. We may have created it, or it might have been created through a piece of analysis that we've done. Well, let's say actually we only want the first element. We just want Monday. So we want a way of being able to extract that single element from our vector of elements. And the way that you do that in R is you give the object, and you open square brackets, and then you give the value of the element the index of the element that you want to extract. So Monday is the first element, so we put days, square brackets 1, and hit Control and Enter, and it returns Monday. So if we wanted to return Thursday, what do you type for? 4, yeah. Cool, okay, so at least that makes sense. Okay, so yeah, if we wanted Thursday, we type 4. If you use a value that is outside the bounds, then it says NA, which is not a number. Not applicable or not available.
What these brackets indicate? So if you put the same number in normal brackets.
So if you were to.
Yeah, what is the difference between the brackets? Because I normally get so confused when I have to put each bracket.
Sure. Okay. So we'll talk more a little bit about functions later on, but brackets like that, round brackets, are used for functions. So you always put the function name, you open the round brackets, and then whatever arguments or inputs are for that function go inside those. Square brackets are always for subsetting. So if you want to take out individual values, then you use square brackets. If a bit more complicated, if you start writing your own functions, then function definitions go inside curly brackets. But those are the only times really when you would use those. So round for functions and square for subsetting. Mm-hmm. If we want to select out just the first 3 days of the week, then, or actually every other day of the week, we say days, square bracket, and then we basically give it a vector of values corresponding to the days that we want. So what does this look like? C to create a vector, and we want day 1, day 3, and day 5. And then you hit Control Enter, and it gives you Monday, Wednesday, and Friday.
So what would happen if you just did 1, 3, 5 without the
like that? It'll complain. So we'll find out a little bit later. But basically, the square brackets are used for subsetting vectors and data frames as well. Well, so for a vector, it needs one value because a vector only has one dimension. Data frame has 2. So what you do then is and we'll do this later on as well, you open your square brackets, you put the index of the rows that you want first, and then the index of the columns that you want second. So what we've just told R to do is take days, index the first row, the third column and the it doesn't know what to do with that instead. So really what we did here is basically gave it 1, 3, and 5 that sort of fits into the first the yeah. Does that make sense? Yeah. Because it seems it doesn't look intuitive when you do it, but it needs a vector of indexes. If you wanted everything except Monday, because Monday's awful, you could do 2 to 4. And hit, but because this, so this creates a vector of values between 2 and 4, so 2, 3, and 4. Let's put this up here so I remember. Hit Control Enter, and you get Tuesday, Wednesday. Oh no, hang on, we forgot Friday, the best one. There we go. Tuesday, Wednesday, Thursday, Friday. If you want all the days except Friday, rather than doing days, well, actually. If you wanted all the days except Friday, how would you do it with a colon? Yeah. So one colon 4. Another way that you could do it is by explicitly saying, give me everything in days except index 5. So -5, and that gives you Monday, Tuesday, Wednesday, Thursday, and it pulls out 5. Okay? So that makes sense how you can select certain values from a vector. Okay, we're still going to go on to data frames, but one thing that I want to talk about before we go to data frames, which actually is fun, I promise, is functions. So functions is really how R does stuff, because without functions, R is just a pretty way of storing numbers and values. So a function is basically, you imagine a box that has inputs into the function. The function does something and gives you an output. And you know that something is a function in R because it has some name. It could be, you don't have to type this, some name that the function has been called by whoever made the function, and then open round brackets. And R knows that this is a function, and it turns it orange because it's recognized this is a function. Some functions don't need any arguments at all. You just give the name. You still put the round brackets even if you haven't given it any arguments. But most functions will accept arguments. So input, basically. It could be a series of numbers. It could be options. And all of those things go inside the curly brackets. So let's create a vector. Create a vector called myValues and make it so that it contains all the values between 1 and 100 without typing each number. So has everyone got something that looks like, oops. Yep. And then if we return myValues, we get it printed out like this. These on the side, by the way, if you notice them, are basically the index of the first value in that row. So this is number 1. This is 18. Obviously, you can read the number. This is 18. This is 19. This is 37. But even if these weren't the actual numbers, that if these were days of the week or names or whatever, this just tells you. It's an easy way of seeing where you are in counting. Okay, so we've got a vector called myValues, and this could be data that we've collected, and we want to know. Okay.
I put without the C.
Okay.
So is it the same or not? Because in the global environment, I've got now the same, so I don't know if I.
Yes. It's the same. You can do either way around. To be honest, that's probably a better way of doing it. So the C in that case was superfluous. So this says create a vector between 1 and 100, but actually the colon symbol does that anyway. So you're right. It's the same thing. So you could do it either way. Mm-hmm. So we've got are values of 1 to 100, and we want to find out what the mean is. And so conveniently, there is a function called mean. So you type the name of it, you open round brackets, and put my values in there, and hit Control Enter. And then R passes your vector of values to mean, and it gives you 50.5. Okay? Other functions, median, which should be, 50.5. Min, which gives you the minimum value. And obviously max. If you've got a vector of values that you want to add together, you can use the sum function. What else? Standard deviation. And a useful one as well. We mentioned data class earlier, so whether something is numeric, character, or logical. If you're not sure, which sometimes might be the case, the function class will tell you. So class my values, and it says integer, just like you said earlier on. So integer is a type of numeric. So basically, if there's no decimal place, then it's an integer, or it's a float or point. And oops, can't spell. Length is useful, which tells you how many elements there are in a vector. Oops, but that was just to demonstrate that R likes the case to be exactly the same, and it gives you 100. You've got 100 elements in your vector. So these functions are predefined. They come with sort of base R. They're there ready for you to use when you open up R. You don't have to define them yourself, although you can make your own functions, which is one of the reasons why R is so flexible. And these functions are summary functions, so they return a single value, basically, whereas other functions will return a different value for every element in your vector. So, for example, if you want to transform your vector, the log function will print out the log values of your vector, but be careful because this is the natural log by default. So if you want the log to the base 10, the function is log 10, and then my values, and then it prints them out. So you can see whereas these guys printed out a single value for your entire vector, these will print out a value for every element in your vector. Another one is, and let's save this as, and you can save the output of any function as an object as well. So if we create an object called my square root, and then we give my square root values, if we then type my square root, we get the square root for every single value in our vector. If you want to do something in R and you don't know how to do it, you don't know what function you need to use to do whatever it is that you want to achieve, Google is your friend. R is open source, and there's loads of help online. So if you want to generate numbers from a normal distribution, random numbers, you type into Google, how do I do that? And someone says, oh, you need to use the rnorm function. And you say, great. How do I use the rnorm function? What arguments do I need to give it? The way that you can find out, R has a really good help function. So if you, help facility, I don't know. If you type a question mark and the name of the function that you want to know how to use, so there's a function called rnorm, which stands for random normal distribution, and hit Control Enter, then you get this help page that opens up in the help viewer on the right hand side. So the package is called, the function is called the normal distribution. It gives you a little description of what the function is, what it's supposed to do. It gives you some example for usage. So this can look a little bit complicated to begin with. basically this actual, it gives you a few different functions here. We're interested in R norm. And the way to read this is, it shows you how to type the name of the function, and it shows you what arguments the function accepts. So the R norm function will accept an argument called n. We don't know what n is yet. An argument called mean, and this is a default value. So if in this usage section of the help, any argument has a default value, it means that if you don't specifically tell R what to use for that particular argument, it'll use its default value. So if you just say R norm, and we'll come to the end in a second, and you don't supply mean or standard deviation, it'll generate numbers that have a mean of 0 and a standard deviation of 1. Or you can specifically tell it what to generate, and it'll do that for you. But if there's an argument that is defined, like n, but there isn't a default value, you have to supply it, otherwise it will have a hissy fit and it will give you an error. So to find out what these arguments are for, or what they do, what they are, what you need to give are, you scroll down to the arguments section, and we're interested in n, and it just says a number of observations. So if we wanted to generate 100 random numbers drawn from a normal distribution with mean of 0 and standard deviation of 1, we would just type R norm 100. Does that make sense? Yeah? And you can do that for any function. So if we type, question mark mean, then we get one for mean as well. So this is a really useful way of learning how to use functions. So we've worked out how to use our R norm function. So we want to generate a random normal distribution with 100 values with a mean of 5. So we know from our example that we type, R norm 100, and we want to set the mean as 5. And if you hit Control Enter, then it produces 100 values whose mean is 5. Another point to mention as well is that R will match arguments by position or by name, which means that I could have also written that. So because in the definition, the number comes first and the mean comes second, even if I don't explicitly say that this is the number and this is the mean, it knows because of position which one's which. Sometimes it's fine to just not specifically define it. For more complicated functions, it can be better to explicitly say, this is this, use the equal sign, which basically says that for n equals 100 and mean equals that. For a lot of functions, the function is written in such a way that often the first argument you don't have to type the name of because it should be obvious in whatever you're doing. But it just so that you're aware that you can do it different ways. Another function is hist, which draws a histogram. And this is nice and simple usage. Hist, it has one argument x, and we'll ignore the ... for now because it's not so important. And basically, the x that it needs is a vector of values for which the histogram is desired. So let's use the hist function. And let's just copy and paste this R norm inside our hist. So if you can put functions within functions. And the way that R will handle that is that it'll do the innermost function first. So it runs R norm, n equals 100, mean equals 5, and that results in a vector of 100 values. And then it passes that vector to the outer function, hist. And so then if we do Control Enter, what we get is a little histogram of our 100 values that appears on the right-hand side. Your histogram might look a bit different to mine because we used a random number generator, so it won't be identical. If you want to make this bigger, then you can always click Zoom, and it brings it up in a separate panel, and you can stretch this and make it bigger as you want it to be, and then close that. Sorry, so up here in the plot area is Zoom, and then you can open it up like that.
And can you directly transfer as a PDF?
Say it again, sorry?
Can you directly transfer as a PDF?
Yes. So if you go to export, you can save the image as, I think, either, what functions is it? Yeah, it's got a few different image functions, but it also has a PDF function as well. So you can save it like that. So is everyone kind of happy how functions generally work and that you pass arguments to them and they give you some form of output that could be a plot or it could be a value? Okay. Okay, so data frames. So this is the last important data structure, and probably the most important data structure if you're working with data and you're analyzing data in R. So a data frame is just a series of vectors pasted together vertically so that each vector, each column represents a different column of your data. So it could be treatment group, it could be time, it could be whatever your output variable is. And there are a couple of ways that you can create data frames. The way that we're going to do it now is we're basically going to make individual vectors and then we're going to paste them all together. So we're basically going to manually create each column of our data and then put them all together. So the first column we're going to call ID, and we're going to assign this to the values between 1 and 200. This could be patient ID. And hit Control Enter. We're going to create another one called group. And to this, we're going to... okay, so this is going to be a vector. And it's going to be a vector of the word vehicle 100 times and the word drug 100 times. So you could spend hours typing them out over and over and over again, but it's going to take you ages. You're probably going to make a spelling mistake there somewhere, and it kind of ruins the point of programming if you're doing things slowly and inefficiently. So we're going to use the repeat function, which is super useful. So you can see at the moment, we've got the repeat function inside the create vector function. And the repeat function takes whatever value it is that you want to be repeated and the number of times that you want to repeat it. So we're going to repeat the character vehicle, comma. So this is now we put the comma so that we can add the second argument for the repeat function. And we're going to do this 100 times. So that's the first vector inside our vector. And the second vector that we're going to paste together with it, with the combine function, is another repeat function. And we're going to call this drug. And we're going to repeat that 100 times. That's probably the most complicated line of code that we've written so far. Does it make sense what's going to happen when we run this? So we create group. And if we call group, we get vehicle repeated 100 times, and then we get drug repeated 100 times. So that makes it so much faster rather than doing it yourself. The next column that we're going to make is our response variable. And we're going to do something a little bit similar to this. So, it's going to be a vector. And this time we're going to paste together two random samples of data. So we're going to use our favorite R norm function, and we want to generate 100 values with a mean of 25 and a standard deviation of 5. This is the first part. Can you see that these are going to be the values that correspond to the vehicle group? If you can't yet, then don't worry. And then the second part of our vector is going to be another R norm call. Again, we want 100. These are going to be the values for the drug group. And this time, we're going to have a mean of 23 and a standard deviation of 5. So that's now the most complicated line of code that we've written. Does that make sense to everyone? What's going to happen? Another thing that you can do, if you start to find that lines of code are really long and confusing and your eyes are going blurry, R is quite happy for you to split lines of code across multiple lines. So if we hit enter here, we can put this on a separate line. And so now maybe this is a bit more readable, that basically R is going to combine together this vector and this vector. And then, but make sure that when you run the code, if you run it from the first line, it'll then run through to the second line as well. And then again, if we just call this, then we've got our response variable with the two random samples that have been combined together. And now let's make our data frame. So we're going to call this my data. And the command to make a data frame is handily data.frame. And then, where are we? You basically give it the column title that you want. So our first column is going to be, oops, that's not how you spell patient. Patient. Sorry, you okay? To rename something, it's probably better off just creating another one and removing the old one. Yeah. Mm-hmm. So the first column is going to be called patient. So you give it the column title, and then the equal sign, and then the values that you want. So patient is going to be equal to the ID vector that we created earlier. Okay. Let's go on to the next line to make it easier for the next column. So the second column in our data table is going to be called treatment. And this is equal to the group vector that we created. And then finally, the last column is going to be called response. And this is going to be equal to the response vector that we created. Okay? And then if you put control enter on the first line of this call, it creates my data. And if we have a look at my data, oops, then you can see that R has printed out what actually, oh my god, hang on, that's quite a lot. What actually looks something like a data table that we might have entered into Excel. So we've got our three columns, patient, treatment, and response. Each one is a vector. So basically what we did then was defined each vector individually, and then use the data frame function to paste them all together into a data frame. What we could have done instead is this. We could have just defined them on the fly. Yeah? Does that make sense? But that isn't very readable. So often it's easier to define each vector individually and then paste them together afterwards. So that's ugly, so let's put that back to where it was. Okay. Another little handy tip. So when you call a data frame, it just puts the whole lot onto your screen and dumps you at the bottom, which often isn't very useful. For a second, let's just clear everything. So if you push Control L, it just clears the console for you, so it's nice and clean. Instead of just being dumped with the entire data set, or sometimes if your data set is too large, it simply won't show all of it to you because it's too big. So there are ways of us being able to explore and understand our data a bit more intuitively than just having all the numbers printed at us. So instead of viewing everything, the head command, let's put this up here. The head command is very useful. What this does is just print out the top 6 values, the top 6 rows from our data table. Say we were interested in the top 10, then you just supply the number of rows that you wanted to show you, and it shows you the top 10 most rows. Similarly, the tail command does the same thing. Shows you that, well, it doesn't do the same thing. It shows you the last 6 values. And again, if I want to see the last 2, then I can do that, and it'll show you that. So rather than seeing everything all at once, if you want to know the dimensions of keep doing that. The dimensions of your data frame, how many rows and how many columns you have, the dim command, if you pass your data frame to it and hit Control Enter, tells you that you have 200 rows and 3 columns. So in our rows always come before columns. So if you weren't sure, although it was quite obvious from my data set, but 200 rows and 3 columns. The structure command, str, is useful, but isn't maybe the most obvious to understand. So it shows you the structure of your data. So it says that, well, you've got a data frame, 200 observations, you've got 3 variables, and then it shows you that the name of each of your variables, each of your columns, and then what the data class is. So patient is an integer, and then it shows you the first sort of 10 or so values. Treatment is a factor with 2 levels, drug and vehicle. So it's clever enough to know that even though you entered it as a character, it's a factor and it has 2 levels. And then response is numeric, and then it shows you the first few values of that. So structure is useful as well. And then finally, summary just dumps a load of summary statistics about your data all at once, which is useful. So for patient, or for response, the mean, median, the quartiles, the max. And for if you have a categorical variable like treatment, then it tells you how many you have in each treatment. So there's a way of exploring your data a little bit and understanding rather than just having the entire data frame dumped in front of you at once.
Can we change the structure? If I would like say that, I don't know, set a number, it's not a number, but it's just a label, let's say genotype.
Mm-hmm.
Can I change it?
Yes. So there are functions that are, so you have the as numeric function. So say we've got character strings like that. Maybe the software that you did your experiment outputted it like that. If you wrap the strings in this as numeric function, it should give you the numbers, so you could change it that way. And you could actually pass an entire column of data to it, and it'll do that. Or you could do as character, and it'll do it like that.
I can use this function on a data frame. Let's say as character and then brackets and then genotype.
Yeah. So
Change
yeah,
all the
exactly.
data.
So we could change the entire column into whatever that you wanted. Yeah. So we've got our data frames. We've created manually in R, and we want a way of extracting certain features from them. We maybe don't want to analyze everything all at once. We want to select certain rows or columns, and you can subset them in basically the same way that we did for vectors. So if we've got my data, the only difference between subsetting vectors and data frames is that you supply 2 values, one for the row number and one for the columns, like we mentioned earlier. So if you want the first row of the second column, you just type it like that, and then you get the value vehicle. And handily, because R knows it's a factor, it also reminds you that you have both drug and vehicle in this column. If we wanted, what's the value of row 2, column 3? Oops. Does everyone get? Oh no, we generated the data randomly, didn't we? So you'd all have different values. Yeah, that didn't work. Okay, but you all type this anyway, right? To get this, the second row and the third column. If you wanted the first 20 rows and the second and third columns, you could say I want. So you're basically creating a vector here between 1 and 20 for the rows, and another one, for the columns. So this is the first 20 rows for columns 2 and 3. If you wanted the first 20 columns, the first 20 rows and all the columns, we just have to leave the option for columns blank, and R assumes that we want everything. And it gives us the first 3. And similarly, we can do it the other way around. So if we want all rows but only want the first column, then we just leave the rows section blank, and it gives us everything for the first column. And it also gives it to us as a vector, you'll see, so it's no longer vertical. You can also call columns by their actual names. So if we want all rows for just the response column, you can do that, but you have to give the name of the column in quotes. And then again, it gives us then all the values for the response column. An easier way of doing this is by using the dollar value, the subsetting value. So if you have a data frame and you want to select a column from the data frame, rather than doing it this way, the shorter hand, the faster way of doing it is just by inserting a dollar sign, and then without having to use quotes, type the name of the column that you want, and it basically tells R, look at my data frame and just give me the column, just give me the column called response, and it does the same thing, okay? You can use logical expressions to pull out rows or columns that meet certain criteria about your data frame. So, for example, let's say we want all values, we want all rows who had a response higher than 26. So, again, we've got our row and column separator. We want all rows for which my data response was larger than 26. So this seems a little bit weird at first because you're having to supply my data twice. But all this is saying is, look at my data and just give me the rows for which the my data response vector is larger than 26, and give me all columns as well. So if we run this, we get all of the data frames, and you'll see that there aren't any values in the response column that are lower than 26. Does that make sense? Because that's really, really useful for quickly subsetting and pulling out certain rows of data that you want. What else can we do?
Create another column telling them more than 26 is positive. So like say in the other column those are positive, and with the same less than 26 negative, for example?
Yes, absolutely. So, yes. So if you want to create a new column in your existing data frame, you just give the data frame. You do the, let's get that way. You give the dollar sign, and then you give the name of a column that doesn't exist yet. And so what R will do is it will create the column for you and then put in whatever values that you've given it. And then use the assignment operator as well. So this should work. No, it doesn't work because we need to give it a why doesn't it work? Yeah, that's why. We didn't actually need to subset. So we just said, basically, look through the my data response column. If it's larger than 26, then it gets assigned a value of true. If it's smaller than 26, it gets the value of false. And so now if we've assigned that to the column positive. So if we now look at my data, we've got an additional column called positive, and it has a value of true or false for.
But this column won't say positive. Will tell true to the positive. So true will be positive.
Yeah, you could do it the other way around. So if I'd done it like this, then it would swap it the other way around. Does that make sense? Let's do something a bit more complicated. So sometimes you want to subset your data based on more than one criterion. So let's do a complicated one. We could do my data treatment is equal to. So when you're doing logical expressions, so something that evaluates to either true or false, the is equal to isn't just a single equal sign, it's a double equal sign. Okay? Just so you're aware. So if we omitted this second equal sign, it wouldn't make sense. So we want the rows where treatment is equal to vehicle, and the response variable is smaller than or equal to 23, and I want all columns. Okay, so that's quite complicated. So we've basically given it, this is the section to evaluate whether it's going to return the rows, and this little bit is for the columns, and we've left that blank. It's going to give us all the columns. We basically said if the value in my data, if the row is part of the vehicle group, and the response is smaller than or equal to 23, return that row. So if we run that, it returns this subset. Does that make sense? So we basically subsetted our data based on combining two separate criteria with a Boolean logic, and, not, or. So if we wanted to do whether it's part of the vehicle group or its response is smaller than or equal to 23, you can use the pipe operator. So this is usually the one next to, you use shift and the key next to Z on your keyboard. And so basically, if a row has a value for treatment equal to vehicle, or its response is smaller than or equal to 23, it'll return that value. Yeah? Does that make sense? Because I know it's a bit complicated, but it's really powerful and useful when you're confident with it. Another one, if we wanted, in this case we've only got two, so we could say drug here. But actually, if you want to say things that are not equal to vehicle, then you use the not equal to operator, which is an exclamation mark and an equal sign. And so basically anything that is not vehicle or has a response of less than or equal to 23 gets returned. Yeah? Is that okay? And we talked about adding a new column. So what we can do is let's define a new vector called age. Let's say our norm, there's 200 of them, mean of 40, and I'm not going to explicitly type them out, and standard deviation of 20. If you just highlight the code and just run that on its own for a second, you'll see that R has a default number of decimal places. And we're only simulating data here, but it would be a little bit silly for people to have ages of 11.871891. So we can wrap this inside the round function. And I will round that off so that we have integer values instead, which makes more sense. And then we want to add this to our data frame, just like we added the other column. So we can say my data $, age, and R recognizes that there isn't already a column called age, so it creates one for us. And this is going to take on the value of age that we just created. And then if we call head of my data, we can see now that we've got patient, treatment, response, positive that we defined a second ago, and age. Okay? So sometimes if you've got small data sets, it might be useful to create data manually in R like that, but most of the time, most of us will probably generate or organize our data into some kind of spreadsheet and then read it into R. Yeah. This will probably be the last thing for today. So you've all got the example data that you got with the email. So what I would suggest that you do is put that in a folder that's accessible to you now, that you can easily get access to. There's a CSV file, which is a comma-separated value file, which is a text file that a lot of spreadsheet programs can open. And there's also an XLSX file because a lot of people work with Excel files. Although it's and you can read those in R, but it's slightly easier to read in CSV files. So they're both in there just to show you the differences for each of them. So we'll start with the CSV file. So the command for loading in, actually let's call this Pokemon. So the function for reading data into R, or reading a CSV file, is read.csv. And then you supply the name of the file in quotation marks. There's a couple of ways that you can do this. You can either supply the full file path of the file, or a much better way of doing it is to set what's called the working directory. So at the moment, if I type in Pokemon.csv is the name of the file, R will say, cannot open the connection, cannot find the file, blah, 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 no such file or directory. And the reason that is because, at the moment, if you don't supply a file path, R has like a default place that it looks for files if you just give it the name. And at the moment, at least for me, it's just looking in this folder. And the Pokemon file isn't in that folder. You can explicitly set your working directory with the set working directory function, but actually RStudio has a much better way of doing this, which is to create a project file. And basically what that does is it sets the current folder that you're working in with your data as your working directory. So if you'll go to project in the top right hand corner and new project, and if you've already got your data in a file, the Pokemon data, then in a folder, then go to existing directory.
So it's asking me if I want to save first.
Okay. Yeah, you can save the file. Save it probably somewhere save it with the Pokemon data in whichever folder that is.
Oh no. And then you save new.
So project, new project,
No.
existing directory, and then navigate to the directory. I actually already have one open, but just actually no, let's do it anyway. And then create project once you've done that. Okay, so it may get rid of the file that you just created. Has it done that? Okay. That's not the end of the world, because everything that we typed up is in the email that you guys got sent, but neater and nicer. So don't worry, it's not the end of the world. So ideally, the way that it is best to work is when you start working on something, create a project at the start, and then you won't lose anything. It's just the way that we're doing it now. No, it'll be set to wherever the R project file is, whatever folder that's in. Go away. Okay, so has everyone been able to do that? No? Yeah, sure, sorry. Okay, so new project, existing directory, and then navigate to wherever the Pokemon files are. Yeah, and then just click create project. In the folder.
Yeah, in the folder I can see that there's the Pokemon.
Oh yeah, that's fine. There doesn't have to be anything else in there. It's just somewhere for there's like an R project file that just sits in there to just remind R that that's where its working directory is.
I can't see with the choose directory.
Can I have a look?
This is the choose directory window.
Mm-hmm.
I see here that it shows file. It's there.
Mm-hmm.
It's fine. I can't see anything in there.
Okay, select the stuff that we've done, but you'll have it in the email.
Sorry,
That's okay.
I have lost everything now.
Yeah, sorry, it's fine. Everything that we've done already, but typed up properly, is in the emails that got sent to you beforehand, or we can resend them out. So
Yeah, if there are people who didn't get the emails, I'll take the registration list here and make sure that everybody who is here has received those files.
Cool. Okay.
So that works.
Yeah, because the best way of working is to make the project first and then do everything else. So if I quickly type get working directory, it now shows me that this is where I've put my file. So I promise we're nearly done. We're just going to read in the Pokemon data, and then that'll be it for today. So we're going to call our data Pokemon, read.csv. The file name is Pokemon.csv. And there's an additional option, which is header, which by default is true, which basically just means whether R reads the first line of your spreadsheet as being column names. So sometimes you'll have data where the first line is headings for your columns, and sometimes it won't be. By default, it's true, so you don't actually have to set that, but it's just useful to know. And then if you hit Control-Enter, because this file is in our working directory, R just looks for this file and just reads it in, and it's happy. So if we type Pokemon, a lot of data is going to come up. And actually what you find is that it can't fit all the columns side by side, and it has to split them. But there's a load of data, and it should look something like that. So imagine that you've got the best PhD in the world. Your PhD supervisor is Professor Oak, and the aim of your thesis is to go and catch them all and to measure things about them. So these are the official data for the first 250 Pokemon. But we can't see everything because there's so much data on there. So we learned earlier about some functions that we can use to explain our data a little bit better. So we can use structure. Oops. And we can see we've got a data frame with 251 observations of 15 variables. We've got the national Pokedex number, NAT, which is just the index of the Pokemon. The name, its hit points, attack, defense, special attack, special defense, speed, the total of all of these values. The main type, and then some of them as well have a secondary type. We can also have a look at head of Pokemon. And then you can see as well that we've got evolves from, evolves into, and then this extra one, captive, that I added.
You had fun setting that up, didn't you?
I did have a lot of fun setting them. Yeah, I mean I didn't do this manually. I found it online, but
Sure.
and then the very last thing. Sorry, I had a spider on my laptop. The very last thing that we'll do today, because although you can save CSV files quite easily from Excel, often people will, for convenience, prefer to work in an XLSX file. The function to read an XLSX file is conveniently XLSX. But if we do this, so now we're reading the other file, not the CSV file. If you do this, R will give an error. Could not find function read XLSX, but it definitely exists. And the reason is that R is a modular language, so it comes with sort of base things, base functionality, and then it has additional packages that you can add into it, a bit like plugins that different people will write, and then you can add in. So if you were able to follow the instructions and install a few packages, this will work. If you haven't, if you go to Tools, Install Packages, and in here just type XLSX, and then hit Install, and then see if that works. But if you've already done that, then you don't need to do that. So you have to install additional packages to be able to use the functions that are contained in them. But also, R doesn't load all of the packages into memory at once, because if you had loads of packages going on, then that could slow things down a lot. So if you want to use a particular package, which is like a library of different functions, then you have to specifically tell R that you want to load them into memory. And the way that we do that is with the library function. So library xlsx, and hit Control Enter, and then R has now loaded xlsx. So it's sort of like a plugin, so we now have access to all of the functions contained within the xlsx package that some person wrote and made available for us. And now, if we run our line of code with the read xlsx function, then it also gives an error, because there's an additional mandatory argument for the xlsx function, which is the sheet index. So often you'll be working in an Excel spreadsheet with data across multiple sheets. So if you wanted to read from sheet 1, 2, 3, then you have to tell R which one you want. So there's only one sheet in our data set, so we want to read from sheet 1. And now if we call head on Pokemon, then again we've got our data. So we've read our data in as a CSV file, and we've read it in as an XLSX file. So I've probably gone on a lot longer than I intended to. Sorry, and I know that was probably some things were quite complicated. I think we'll stop there for today, and then next week we'll spend some time exploring the Pokemon dataset and analyzing it and doing t-tests and ANOVAs and things on it. Is there anything that anybody has any questions on now, or anything I didn't explain very well, or want me to go back over, or if you've got specific questions about what you want to do in R?